You are sitting in seat 14A. The cabin is quiet. The hum of the engines is almost hypnotic, and you are sipping a warm cup of coffee at 35,000 feet. You feel safe. You trust the aluminum tube cutting through the stratosphere. But right beneath your feet, just inches away from where children are sleeping and people are reading, is one of the most volatile environments on Earth. You are casually hurtling through the sky while sitting on top of nearly 40,000 gallons of highly explosive aviation fuel. If you were to look out the window right now, you would see the wings slicing through the clouds. Most people think those wings are just solid pieces of metal, carefully shaped by aerodynamic laws to keep the aircraft aloft. They imagine the fuel, the lifeblood of this massive machine, is safely hidden away in some armored vault deep within the belly of the plane. But the truth is far more unsettling. Those wings are not just lifting you, they are holding the very explosive power that could tear the sky apart. The wings are the tanks. You are suspended in the air by two massive floating pools of kerosene. Why would the world's most brilliant aerospace engineers take a perfectly good flying machine and pack its most vulnerable, exposed, and fragile extremities with thousands of gallons of flammable liquid? Why not put it in the center, where it is protected? It feels like a catastrophic design flaw. It feels like a ticking bomb waiting for a single spark, a single bird strike, or a single structural failure to ignite. Have you ever really stopped to think about the sheer mechanical audacity required to keep you alive up there? We board these massive machines blindly, trusting a system we barely comprehend. Those who take a moment to look deeper into the shadows of aviation design usually find themselves questioning how we ever dared to conquer the skies in the first place, and perhaps realizing that true safety is just an illusion masked by clever engineering. The answer to this terrifying design choice isn't born out of convenience, it was born out of a desperate mathematical necessity. If the fuel were stored where logic dictates it should be, none of us would survive the takeoff. The next time you walk down the jet bridge, you might want to pay closer attention to the shape of those wings because they hide a secret that engineers rarely talk about with passengers. The very thing that makes the wing a flying bomb is the exact same thing that prevents the aircraft from snapping in half mid-flight. To understand this paradox, we have to look at the invisible forces trying to destroy the plane the moment the wheels leave the tarmac. Gravity is not the enemy here. The real enemy is the airplane's own weight. When a massive airliner sits on the runway, it is a dormant beast weighing hundreds of thousands of pounds. Every piece of cargo, every passenger, every piece of metal is pressing down toward the earth. But the moment the engines roar and the plane accelerates, a violent tug of war begins. The wings start to generate lift, pulling upward with unimaginable force, while the heavy fuselage, the main body where you are sitting, is being dragged down by gravity. Imagine holding a heavy brick with your arms outstretched. The tension on your shoulders is immense. Now imagine if those arms were thin, hollow metal structures trying to lift a multi-ton steel tube. Under normal circumstances, the upward force of the lift and the downward force of the cabin would cause the wings to simply snap off at the root. It is a structural nightmare. Engineers realized early on that they could not just build thicker, heavier wings because then the plane would never leave the ground. They needed a counterweight. They needed something heavy enough to push the wings back down, counteracting the violent upward lift, yet useful enough to justify bringing it along. Imagine what would happen if we actually followed our basic common sense. Imagine if we took all that highly combustible fuel out of the wings and placed it safely inside the belly of the plane, far away from the engines and the fragile wingtips. It sounds like a perfectly rational safety measure, but in the unforgiving realm of aerodynamics, Human common sense is often a mathematical death sentence. If you were to load 40,000 gallons of dense liquid into the center fuselage, you would create an insurmountable concentration of mass right in the middle of the aircraft. Now picture that heavy fuselage speeding down the runway. As the aircraft gains speed, the wings do exactly what they were designed to do. They catch the air and violently pull upward. But the body of the plane, now burdened with the colossal weight of all that fuel, wants to stay dragged to the ground. The exact point where the wing connects to the fuselage is called the wing root. If the fuel were stored in the center, this joint would suddenly be subjected to a terrifying amount of mechanical stress. The wings would desperately try to fly upward, while the immensely heavy body would drag downward. Within seconds of leaving the tarmac, the sheer leverage would be too much for any known metal to withstand. The wings would bend, fold upward like a fragile object caught in a crushing vise, and ultimately snap clean off the aircraft. The very design choice that seems intuitively safer would guarantee a catastrophic structural failure before the plane even reached the clouds. This is the terrifying brilliance of modern aerospace engineering. The designers did not put the fuel in the wings simply because it was empty space. They put it there because they desperately needed the weight. By spreading those tens of thousands of gallons of heavy liquid evenly across the entire length of the wings, they created a perfectly balanced counterforce. As the violent air pushes up against the bottom of the wing, the immense weight of the fuel pushes down from the inside. The terrifying forces cancel each other out. The fuel essentially acts as a structural stabilizer, absorbing the brutal stress of flight and keeping the wing firmly in place. It is a haunting paradox to accept. The highly explosive liquid that you instinctively fear might cause a disaster is the exact same physical weight holding the entire aircraft together right now. Without the heavy burden of that fuel pushing down on the aluminum, the plane would literally tear itself apart. But solving this gravitational nightmare created a completely different kind of monster. If the wings are essentially just massive hollow shells holding thousands of gallons of loose liquid, how do you stop all that immense weight from violently sloshing around and throwing the plane completely out of the sky the moment it hits a storm? Most people assume that inside the wing of an airplane there is a series of strong metal barrels or reinforced rubber bladders securely strapping the fuel in place. They imagine a separate, heavily protected container hiding safely within the aluminum shell. But if engineers actually did that, the added weight of those heavy internal tanks would make the aircraft entirely too heavy to fly efficiently. So they did something that sounds borderline reckless to the average person. They didn't put a fuel tank inside the wing. They turned the entire wing itself into the tank. This is known in the world of aviation as a wet wing. When you look out your window and watch the wing flexing and bouncing in the turbulence, you are not looking at a hollow piece of aerodynamic metal. You are looking directly at the outer wall of a massive, sloshing swimming pool of aviation-grade kerosene. Every single rivet, every single overlapping seam, and every microscopic gap in that aluminum structure has to be painstakingly sealed by hand with a specialized aerospace compound. If just one critical seal fails under the immense pressure and vibration of flight, the fuel will seep out into the freezing air, atomizing into a highly flammable mist trailing right next to the scorching hot exhaust of the jet engines. But a wet wing creates a terrifying physical problem that could easily doom the flight. Imagine carrying a large, shallow tray of water across a room. As you take your first step, the water immediately rushes to one side, completely throwing off your balance and nearly twisting your wrists. Now, scale that up to tens of thousands of gallons of heavy liquid trapped inside a metal tube traveling at 600 miles per hour. If all that volatile fuel were allowed to freely rush to the very tip of the wing every time the plane banked for a simple turn, the sudden shift in gravity would violently flip the massive aircraft completely upside down. To prevent this fatal shifting, the inside of the wing is designed like a claustrophobic mechanical labyrinth. It is intricately built with a series of solid metallic walls with strategically placed holes known as baffles. These baffles act as structural ribs, giving the thin wing its incredible strength, but their true life-saving purpose is to trap the fuel. They force the heavy liquid to move slowly and deliberately from one small compartment to the next, entirely stopping the catastrophic tidal wave of kerosene that would otherwise rip the plane out of the sky. Yet even with this brilliant labyrinth keeping the massive weight stable, the engines are constantly, aggressively draining it. Every single second you remain in the air, the massive turbines are sucking gallons of fuel out of those wings to keep you moving forward. And this creates an entirely new nightmare for the pilots sitting in the cockpit. Because if the engines do not drink this fuel in perfect symmetrical harmony, the aircraft will slowly begin to tilt toward its own destruction. Every minute you are in the air, the massive jet engines bolted to the wings are burning through gallons of fuel. But they rarely burn it at the exact same rate. If the left engine consumes just a fraction more fuel than the right engine, the left wing becomes lighter. Slowly, imperceptibly at first, the lateral balance of the aircraft begins to shift. If left completely unchecked, the heavier wing would violently drag the plane down, causing it to roll uncontrollably into a fatal spiral. To prevent this, hidden deep within the belly of the plane, a completely automated network of pumps and valves is constantly fighting a silent war against gravity. Without any direct input from the pilots, this electronic brain is constantly transferring fuel back and forth between the wings, meticulously maintaining the fragile equilibrium of the aircraft. You are kept perfectly level, not just by the wind, but by a continuous high-stakes balancing act of liquid weight. And as if the threat of structural failure and catastrophic imbalance was not enough, there is an even more hostile enemy waiting just outside your window. At cruising altitude, the temperature drops to a bone-chilling -60 degrees Fahrenheit. You are essentially flying through a frozen wasteland. The aluminum skin of the wing is subjected to this extreme cold for hours. By all laws of nature, the tens of thousands of gallons of liquid fuel pressed right up against that freezing metal should turn into a solid, useless block of ice, starving the engines and sending the plane plummeting back to Earth. So why doesn't it? The answer lies in a terrifyingly brilliant piece of thermal recycling. The jet engines generate an immense amount of friction and heat, and the oil keeping those internal turbines running gets dangerously close to boiling. Engineers designed a closed system where this blistering hot engine oil is routed back through a network of pipes directly into the freezing fuel tanks. The blistering heat of the engine oil warms the freezing fuel, keeping it liquid, while the freezing fuel simultaneously cools down the engine oil, preventing the turbines from completely melting down. It is a perfect, continuous loop of survival.
The freezing sky and the burning engines are forced to keep each other in check, just inches away from where you are sitting. The next time you fly, look out at that wing, look past the painted metal and the rivets, realize that you are sitting inside a fragile ecosystem of explosive liquid, extreme temperatures, and brutal gravitational forces, all perfectly balanced on a mathematical knife's edge. But balancing the fuel is only part of the equation, because if you look closely at the tail of the plane, you might notice a strange dark hole at the very back. Most passengers never see it, and airlines certainly do not advertise what it actually does. But if that hidden engine inside the tail ever stops working, everything we just talked about simply ceases to matter. Have you ever wondered what is hiding in the dark at the back of the plane?